All right, let's start over. Maybe I should do that. I'll do that one day. That is ridiculous. That is ridiculous. Why are you joking around so much? Okay, so what are we doing? We're talking about the abacus. This is the abacus, and hello, hello, Maddie. I'm just being silly. Sorry. What we're doing is we're reading the abacus. Before we understand how we do things, we're going to understand how to read the abacus. The reading of the abacus is kind of important because then we can actually do some adding and subtracting on the abacus. Now, if you notice, what we're going to do is we're going to count one. This is one. When we look, right, we have our top beads, we have our bottom beads. We have our top beads is up here. We have our bottom beads down here. Then we have this thing right here. This is called a beam or a horizontal bar or a reckoning bar. So we have our bottom beads and our top beads. This is the anatomy of the abacus. With the abacus, what we're doing is we're just going to count. We can add, subtract, multiply, and divide. So when we're looking at it, oh, that's interesting. When we're looking at it, right? If I want to do zero, zero looks like this. Zero just means that there's no beads touching this horizontal bar. That's what that means. When we're looking at a horizontal bar, we only know what's being tracked. So this is one. So on my abacus, on my number, this is one. When I'm looking, right, I know that this bead touching this horizontal bar is one. So if I wanted to, I could do this. This is all one, 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 one. And then if we have, this is zero again, we're going to zero it out. When we have two, notice I have two beads touching this horizontal bar. This is two beads touching the horizontal bar. If we did this would be two, 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 two. Every column has two. Now we have three. After three, right? That's three. So this is two, 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 three, two, two. But then if I move everything up like that, then this is all three. And then we have four. Well, we have three, 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 four, three, three. But if we moved all of this up, now we have all fours. Does that make sense? So, well, that's how we did. That's all we're doing. No, 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 no. There's more. But wait, there's more. We have five. How do we do five? Five is all like this. What did I just do? I just moved all my beads down, and that's when I zero it out. When I do this, this is now five. So these are all fives. And then we do six. Six is five plus one. But right now we have five, 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 six, five, five. But if I move all these up, now we have six. And then we have seven, right? Seven looks like this. We know what seven looks like, Lynette. We know what it says, right? So this is what it looks like. Six, 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 seven, six, six. So we move all of these beads up. Now these are all sevens. We have seven, 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 seven. And then we have eight. Notice it's five, six, seven, eight. This is eight. We have five, one bead on the top, which is a value of five, plus the three is together. It is now eight. But this is 7777877. So if I'm going to move everything up like this, now we have 888888888. And then we have 9. 9? What? Yeah, 9. So we have 5, 6, 7, 8, 9. Anybody have any questions? So when we're going through all of the columns, right, we have 8888988. And then if we move all of these up, now we have 9999999. Cool? All right. How are we doing? Are we all right? What we're doing is we're learning how to read the abacus. When we learn how to read the abacus, we can actually start going into adding, subtracting. But the first thing we're going to do is we're going to understand how to read the abacus. But then, wait a minute. What happened to 10? Well, funny, you should ask. Funny, you should ask. Funny things are. Anyways, what 10 is, interesting. What 10 is, if I zero it out and I have a 0, and we know what 1 looks like. That's what 1 looks like. But notice it's on a different column because we have our 1s and our 10s. When we label it, I can label it. Every column is a label. Every column is a place value. So when we're looking, we have 10. 10 looks like 0 and 1. 1, 0. Just as how we write it. 1, 0. And then we have 11. After 11, right? 1 and 1. That's how we do 11. And then we have 12. How do I know that this is 12? This is 1 and 2. 1 on the tens column, 2 on the ones column. So when we're writing it out, just as how we write it, it would be 1 and 2. When we're looking at 13. That's not 13. That's 13. 13 looks like that. And then we have 14. And then we have 15, 16, 17, 18, 19. That's 19. And then what do? We do 20. 20 looks like this. 2 and a 0. Just as how we write it, right? 2 in the tens column, 0 in the ones column. And then we can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. And then we can do 100. 100. And what we're doing is we're just looking and understanding how the beads are on the abacus. So 100 is 100. We can count it, right? We can do 101, 102, 103, 104. And then we do 105, 106, 107, 108, 109, 110. 110, right? Just as we write it, it looks very familiar, doesn't it? It's just a 110. Cool? How are we doing? Oh, righty. All right, we're going to continue on because what are we going to do? Because we can add, subtract, multiply, and divide. Live comments that will appear on the screen during your stream. That's interesting. All right. Anyways. All right. How are we doing? We're all right? Okay. What we're going to do is understand. Okay, we did this. Now, what are we going to do? Well, let's do a couple more. Let's see how we are. Hello, Sarah. Okay. Oh, that's the wrong one. What we're going to do is we're going to do some bead recognition. Hey, Mr. Clean. Welcome, Mr. Clean. How are you today? Are you out of school already? Or are you in school and you're watching me? Because somebody did that. Who did that? Somebody did that. And they showed me to their teacher. And I'm like, why are you showing me to your teacher? You should be at school paying attention to your teacher. And they're like, no, it's fine. They like to watch, they want to watch your live to see what I'm talking about. Because I'm trying to make sure it's all educational because you're learning. I need to make sure you're learning. Hello, Mr. Clean. Hello, Mr. Clean. Are you in school or are you out? What is today? Today is Thursday. Today's the 23rd. Some people are already out of school right now. Okay, so what are we going to do? We're going to do two-digit mazes. What this means is we're going to go through. Oh, I didn't. This is a maze. And what this means is that I'm out of school today. Is it only today's Friday? Oh, is it because it's a long weekend, Memorial Weekend? Oh, you lucky. And I'm so happy you decided to join me on your day off. I feel very honored. Thank you for joining me on your day off. I'm so happy that you're here. Yeah. Oh, okay, good. All right. So what we're going to do is we're going to read the abacus, right? And what we're going to do is we're going to follow this maze. When we follow the maze, you're going to answer the question. Here, if I have this number, what number do we think this is? If this number is my tens and my ones, and when we're looking, we have my tens and my ones, what number is this? So if I add my tens and my ones, that's what number. What number do we think that is? Oh, Mr. Clean, I think it's just you and us, you and me. If it's just you and me, is there anything specific you want to ask? Oh, there's Zach and Javier and Angie. 91. Thank you so much. Thank you so much. If anybody else wants to chime in, go ahead. But this is where we start doing some bead recognition and understanding how to read the abacus. So what we're doing is we're going to do this number. So if this is my tens and this is my ones, what number do we think that is? Thank you, Mr. Clean. So what number do we think that is? Thank you. 92. It is 92. How do I know this is 92? Because this is 5, 6, 7, 8, 9, and then 2. 1, 2. At least you didn't forget. Because it's been a while since you came on board. So if I have this number, right, I have my ones and my tens. So what I'm looking for is my tens and my ones. If I have my tens over here and my ones are over here, just as how I have, what number do we think that is? Because every number, right, we have the horizontal bar, the beads are touching the horizontal bar. So when we're looking, We have our, I saw your TikTok on the, I saw your TikTok off with your dog. Yeah, thanks. Yeah, she's a German Shepherd. 15. Yes, Javier. Yes, exactly. Why is it 15? Because we have our 1 here and we have our 5 up here. So together it is 15. You're absolutely right. So 15, and then we're over here. I don't know what number that is. Okay, there we go. We can see that number. So when I have my tens and I have my ones, I have my, this is my tens and this is my ones. Just as we had this as your 15, right? It also translates to here. So if we have our tens and then we have our ones, what number do we think that is? Thank you, Mr. Clean. Yeah, I'm trying to teach my dog how to do abacus. Thank you, Javier. Yes, 52, because this is a 5 and this is a 2. Thank you, Moldo and Mr. Clean. We have 5 and a 2. This is my tens, this is my ones. So I have 52, 1, 2, and goes down to here. What number do we think this is? My tens, right? If my tens is like this and my ones is like this, what number do we think that is? I'm not sure if my other dog will be able to understand abacus. 78. Yes. How do I know? Because this is 70. This is my tens. 5, 6, 7. Thank you, Zach. Thank you, Javier. Thank you, Mr. Clean. So then this is 8. 5, 6, 7, 8. So what we're looking at is we're looking at 78. So we're going to follow the line. It goes over here. And then we are now over here. And then we have 0. Ooh, this is my tens and this is my ones. What number do we think that is? And I gave you a little bit of a hint. Yes, thank you, Mr. Clean. It is 5. That's it. That's all it is. It's just 5. Thank you, Javier. Right? And so when we're going to follow the number, we go 5 and we go down here. And now we have, oh, I can't see that one, Lynette. Sorry. So, oh, this is a great question. This is my tens and this is my ones, right? So the last two numbers would be like the decimals in the scenario. Yes, exactly. Exactly what that means. So when we're looking at it, it is not, oh, it is 5. Thank you, Lane. This is not 16. This is 20. We have a 20 in our tens column, and then we have 9. Thank you, Mr. Clean. We have 9. We have 5, 6, 7, 8, 9. So we have 29. That's what 29 looks like on the abacus. So, Maldo, just so you know, what we're doing is when you read the abacus, we have our ones, our tens, our hundreds, our thousands, our 10,000. So in this scenario with the decimals, it would be like money. So if I have $1.15, right? $1.15. If I did $2, $1.25, that's what it'd be like. That's what the decimals are. So we did 29, it's over here. Does that make sense, Maldo? So what we're doing is on the abacus, we could see where our money, we can count our money on the abacus. The dot right here, this is my ones indicator. My ones indicator tells me my ones place. And then everything after that would be my decimals. Notice my decimal doesn't sit on a place value. It sits between, just like in regular math, right? Just in regular when we write it. So when we're looking, oh, thank you, Priscilla. Reseda. Yes. So we have our tens and we have our ones. So we have our tens and our ones. Yes, it is 24. So we're down over here. And then we can't see that. So, Maldo, did that make sense? So we have, hello, Jennifer. Hello. How are you today? So we have our tens and we have our ones. Now, what number do we think that is? Our tens and our ones. When I have my label, we can do tens and we have my ones. 77. Thank you, Javier. Yes, 77. And so we go 77 and we're over here. And then this is my first time learning this. This is great. You're doing so well. You're doing really well, right? It's easy, right? 37. Oh, no. No, because this is a 5, right? These are my tens and these are my ones. This is 0 and this is 6 because it's 5, 6. 0. So when we're looking, it's 0, 6. And then, yes, thank you, Mr. Clean. It is 6. So we're going to go up here. We have a couple of more. And then we have, oh, this is almost, right? So if I have my tens, I have my tens and my ones. My tens is over here, right? How many tens do I have? One, two, three. And then I have ones. This is my ones. So I do that. So what number do we think that is? Thank you, Mr. Clean. It is 31. How do I know it's 31? Because it's 30, 1, 2, 3, and it's 1. So there we get 31 on the abacus. Does that make sense, Rosita? And then our final answer is survey says. So if I have my tens and my ones, I have my tens, and then I have my ones. Thank you, Jennifer. So my final answer, my final question is my tens and my ones. What number do we think this is? 24. Good job, Javier. Good job. Yeah. Easy, simple to use, easy to understand. Thank you, Jennifer. Thank you. Thank you guys for participating. Cool. So that is my maze. And so what I did was, oh, I should. What I did was, this is the maze. This is a lot about bead recognition, and this is only 2-digit right now. And then there's another one I called a reverse maze. So what the reverse maze is, I give you the number and I give you a path, and you're supposed to color it in. So what does that mean? Well, here's my maze, what I'm going to, what I give you, right? This is how to get to the start and to the finish. But the thing is you need to color in. Excuse me, you need to color in the abacus. So you look at the number that says 54 and you color it in. And that's what I did here. So if I had 54, I color it in. I have 96, then I color in 96. And then I have here is 29, and I'll color in 29. So this is what I call a reverse maze. Yeah. The reverse maze also just talks about how to read the abacus, and that is available. That's available here in my shop. Yeah. Okay. So, do we have any questions before I move on? Because what we're going to do is we're going to start moving the beads. We're going to start understanding how to move the beads. So this is my preschool one, because preschool doesn't know what numbers are. So I made some worksheets to explain what the numbers are and how it works on the abacus. This is about adding and subtracting, and this is moving it. It's yes, Gia, yes. It's seeing the patterns are very helpful. You're absolutely right. You're absolutely right. So if I show you, I can do 5 times table, 5 times table. It's very interesting, and so you'll see that there's a pattern for the 5 times table. There's a couple of things that we need to understand, right? There's a couple of things we need to understand. It's like, how do we make a 5? But you'll see that there's a pattern. So if I do 5 times 1 is 5, and then 5, and then we add another 5, right? We don't have enough beads to add the 5. So what are we going to do? We're going to plus the 5 minus the 10. And then what's going to happen, right? We want to add another 5. Can we add another 5? Yes, we can. So we're going to add another 5. So right now we're at 5 times 3. When we're looking, we want to add another 5. If you look, we need to use another formula. We need to use the same formula, right? This is the same formula. Formulas are being used because we don't have enough beads. I might be jumping ahead. Maybe what I'll do is go back. Let me go back. Okay, so the first thing we're going to do is we're going to understand how to move the beads. Visual learning helps me. Yes. I have a few people that have dyscalculia, and I have a few people that have ADHD, and I have a few people that come in and saying that they have dysgraphia. And most of them, if not all of them, says that the abacus really helps. But it's different, right? It's different because I have it and I'm touching it. But if you have one, it'd be better. Our brain, and it's interesting. Like, what I notice is when I see a picture, it's still not the same when I see the physical abacus being moved. So what we're doing is we're understanding how to move the beads. In abacus world, we always want to look at the add-in. We do not want to look at the result. That's the thing. Hey, Neon! Welcome back, Neon. Okay, so what we're going to do is understand when no matter how big and burly your hands are, right? No matter how big and burly your hands are, you want to make sure that you're going to just use the edges of the beads. That's why the beads are the way it's designed. So you just use the edge of the beads and you want to be gentle. So when you're being gentle, right? We're being happy. We're being happy when we're doing abacus. We're being happy when we do math. So when we're being happy, I want to do 1, 2, 3, 4, right? And then we have 5, 6, 7, 8. So notice what I'm doing is I'm just moving, I'm just using the edges of the beads, right? And then that's the other thing is it's very easy to move. This is very common, right? So if you bump your abacus, your answer will be wrong. So you want to make sure you want to use your left hand to stabilize the abacus, and you can use your right hand to do the calculations. Even if you are left-handed, you can you even if you're left-handed to write, you could still hold the abacus with your left hand and you use your right hand to do the writing. Yes, Mr. Clean. You can't be mad while doing math. And you don't want to be aggressive. You don't want to be aggressive because all your beads will get messed up. So that's the other thing, right? You want to be gentle. And then the other thing is, oh yeah. And then the other thing is you don't want to, and you flick too hard. Don't flick too hard. Oh, have a good weekend, Gia. Happy to see you in my live. Hopefully I'll see you again in my next live. So what happens is what we're doing is we want to make sure we don't flick too hard because whenever the beads are not touching the horizontal bar, we don't want to, we do not want to have the wrong answer. Good morning, Riley. How are you today? You came back. Is your the vacation was good? Yeah. I appreciate you joining my live on your day off, just like Mr. Clean. I appreciate you guys joining me on your day off. Thank you guys. I appreciate that. Okay, so Javier is still here or Gia left. If there's nobody else, I mean, we can go on to like more complex math. I didn't want to leave. What the complex math just means we'll be doing arithmetic and adding, subtracting, multiplication, division. So I'm not sure if Javier is still here. If you're still here, let me know. Okay, good, good, good. So we're going to continue on, right? I'm going to continue on like going through the whole how to use the abacus. So again, what we're going to do is we're going to focus on the add-in. We're not going to focus on the result. We want to marry the process and divorce the result, right? Marry the process, divorce the result. What does that mean? What we want to do is we want to understand when we add the 5, right? We're going to add the 1. Is there enough beads to add the 1? Yes, we can add the 1. So we're going to add this 1. That's all that means. When we add, we go to the horizontal bar. When we subtract, we go away from the horizontal bar. So what are we trying to do? We're trying to do is we're looking at the beads and how they move. When we're moving the beads, right, we go to the horizontal when we add. So here I have my question, right? If I have 7, this is 7 on my abacus, and then I add the 1. When I add 1, again, I'm going to the horizontal bar. Okay, okay, okay. I know that already. Good. So then if I do 2, it's the same thing. I want to do 2. You want to add to the horizontal bar. And again, if I subtract, I go away from the horizontal bar. So in here, here's my question. I do 6, and I want to add the 2. I add the 2. That's all I'm doing. I'm just adding the 2. Does that make sense? So what we're doing is we're understanding how to move the beads. Oh, come on. Okay, good. Okay, and then it's the same thing with the 2s and the 3s. So in the 3s, right, you could do 5, right? We could do 5 and then plus 3. When we add the 3, we're doing plus 3, right? So we know that this is 8. We've done this before, right? We've seen this before. So it's 5, 6, 7, 8 when we look at it, right? So what I'm doing is I'm checking to see if we can move the beads. That's always the question. Here in mainstream math, you could add in 5 dots and 3 dots and then add them together. You could do that. Or you could do it on the abacus and just see, oh, 5 plus 3, there you go. Easy peasy, right? And so it's the same thing with the 4s and the 5s and the 6. So we did the minus 1, right? We did minus. If I have 2 and I want to take away 1, I'm going to take away. So after this, can you show us double digit multiplication? Yes, I can. Javier, don't get scared. Right? We'll do this. We'll do that. But the first thing I want to do is understand. I want to explain like how to add, right? So we're okay. Does that make sense, Javier? Do I want it? Should I keep going? I won't. Okay. Okay. Good. So this makes sense, right? So when we're doing it, we want to move the beats. Well, what happens, right? What happens when you? Hey, Jackson Coke, welcome back. Okay. Before I continue, right? What happens when I don't have enough beats? This is where we get to formulas. Formulas is what? Formulas is when they start talking about when there's not enough beats. What we need to do is we need to understand that if I don't have enough beads, I need to start using this. We're teaching the kids these math sentences, but we don't teach them why. I don't know why. But in Abacus, let me show you in a little bit. Okay, yeah. So here's my question. My question is 3. So on my Abacus, I have 3. I have 3 on my Abacus. And then I have So I have 3 on my abacus. One, two, three. I don't know where you are in the world, but I have 3 pennies. Pennies is worth 1 cent, right? I have to have 4, but because I have 4, my question's not there. If I have 4, right, I don't have any more beads. I don't have any more beads. But you know what? I do have a nickel. I have 5 cents. Because I have 5 cents, I can give you this 5 cents, but it's too much. Because it's too much, I need an exchange. So if I'm going to add the 5, I got to take away the 1. So if I add the 5, I take away the 1, and then we're done. So my final answer is 7. Does that make sense, Javier? So we're going to understand, right? We do it again. If I have 4, I'm going to add the 4. When I add another 4, I don't have enough. What do? I take this nickel and I give you my nickel, but guess what? That's too much. So I give you my nickel, that's too much. I need to take away the 1 and take away the 1. So my final answer is 8. Is that all right, Javier? Okay. Yeah. Okay, good. So there's 2 sets of formulas, right? I love how satisfying. Okay, before we go into multiplication, let me do one more thing. So the next thing we're going to do is we're going to understand. I'm blowing through this, Javier. So let me know if it's too fast for you, and I will slow down. But let me know if you get any confusion. Right? It's not. Don't be confused because I get annoyed if I get confused. So you let me know, okay? Hello, Principal Martin. So the first thing we're going to do, so the second thing, the third thing, anyways, the next thing we're going to do is we're going to understand how to make a 5, right? To make a 5, so that's the idea of understanding how to use formulas, right? So we understand how to use the formulas. We could do 1, 4, 3, and 2, right? All of this is 5. That's what this 5 is for. So we could do 3, right? When we add 3, right? We add 3. We want to add another 3. We can't add another 3, right? Okay. Okay, good. Okay, good. Then I'm just going to blow through this. So, thank you, Javier, for letting me know. Yes. So, what's the next thing we're going to do is we're going to understand how to make a 10. So, making it a 10 is really kind of cool. Why? Because this is when we start using the next column over. And that's when we start doing this one. Let's do 5. Let's do 5 because 5 is a very fun number. 5. So in Abacus, right? In mainstream school, we're teaching the kids how to make a 10. That's fine. In Abacus, we actually take this information and then we do some modify. So when we isolate this variable, what we're going to do is we're going to isolate the variable and we're going to move this 5 over here. So that means I'm going to do that. So when I do it, when I want to add the 5, it is 5 is equal to plus the 10 minus the 5. So what I'm going to do, right? Why am I going to do that? So if I have 5 and I want to add another 5, all I have to do is plus the 10 minus the 5. I have now instructions how to add the 5. So when we add the 5, so what I'm doing is I'm doing 5 times table. Here's another question. If I have 9, I want to add the 5, I'm going to add the 10, right? 10 is just 1 0, 1 0, and I minus the 5. My final answer is 14, right? So what did we just do? We powered up our addition sentence, and that's what we did. We powered it up, so we actually utilize it, and now we are utilizing all our numbers, and that's it. That's it. We're done. Okay, let's do some. Okay, let me do a couple more things. So here's another thing. This is a really big question. It is a very big question, but you know how easy it is? It's very easy because you need to see it. So when we have 1,357.8, no, that's wrong. 13,578, right? What we're going to do is we're going to add 27,000, 24,311. We're going to add the 2. Is there enough to add the 2? Yes, we can add the 2. Here, I want to add the 4. Can I add the 4? No, I can't add the 4. But wait, we know how to add the 4. Remember with my my nickels, right? If I want to add, if I have 3 and I need to add the 4, what do? I take my nickel. Thank you, Mr. Clean. I'm going to add my 5 and I take away the 1. And then, can I add the 3? Yes, we can add the 3. Can we add the 1? Yes, we can add the 1. Can we add another one? Yes, we can add another one. So my final answer is 37,889. Make sense? And we can do it again. So now what we're doing is we're understanding that we can do more than just that one column, right? So you learn the fundamentals, you learn the basics. Because you learn the basics, you learn the elements, we can go everywhere with it. So if I have this one, right? If I have 26 and I want to add 32, I want to add the 3, I want to add the 2. I don't have enough beads to add the 3. What do? I know how to add the 3. What do I do? How do I do it? Do you remember, Mr. Clean? If I want to add the 3, what do? I plus the 5 and I take away the 2. And then can I add the 2? Yes, I can. All I got to do is add the 2. So my final answer is 58. Cool. Yeah. Thank you, Jackson Coke. All right. So does that make sense? So what we're doing, thank you, Mr. Clean. So what we're doing is we're understanding the basics. We're understanding the fundamentals. This is easy. Somebody gave this to me. I was like, what? So we had 283, right? 283. Can we add? Yes. We don't need to make friendly numbers. We just add it. We just look it on the abacus. Can I add it? Yeah. Add the 5, add the 1, add the 1. 794. All right. That's it. That's it. That's everything about adding and subtracting. Oh, okay. So, Mr. Clean, we wanted double digits. Oh, I didn't do that. Okay, hold please. I'm trying to look for. Thank you. Let me see. Multiplication. Where is it? Oh, yeah, this is beautiful. Okay. Did I do it? No. Hold on. Hold please. Trying to do. Okay. No. That's. Oh, yeah. Okay, got it. Okay. So, let's see. Show double digit multiplication. Yeah, this one was a really beautiful one. Not that. It was. Okay, let's see. So I'm trying to find some really nice, pretty questions. I think it was this one. Okay. Can we do that one? Okay, we'll do that one. So, I need paper. Okay. Okay, wait. Can I see your piece of paper where you show the? Yeah. This one? This one are you talking about? That one? Right? So this is our formula. 3 plus 2 is equal to 5. Then we do some power up. And then we isolate the 3. And then we do 5 minus 2. Good morning, Jose. Good morning, Panda. How's it going? It's been a while since I've seen you. Is that the one you were looking for? Okay, so then if you look, right, we have, yeah. So here I added a what we call cumulative property, right? And we have all of them. This is all adding and this is all subtracting. And they work exactly the same. So when we're looking, right, they look exactly the same. The only difference is you change the sign. Yes, Principal Martin, it is. It is the Abacus is the gateway to complex math, and we use a lot of algebraic formulas and we use a lot of algebraic concepts, but we don't do algebra in Abacus because we know what the numbers are. I'm crazy. I haven't been on TikTok lately. Oh, interesting, Jose. Yeah. Yeah. So, and that's the other thing. The interesting thing about Abacus is it also provides critical thinking. So what the critical thinking means is there's a framework to go through every number, and we haven't gone through it, right? No, thank you, Javier. Thank you for your questions. Let me know, please. Let me know anything you have questions with the abacus because yeah, I don't like to be confused, and so that's why we're focusing on the add-in. Yes, exactly. So we always want to know is what we're trying to do. We want to marry the process, right? We want to know what the journey is. We don't need the destination. So when we are looking at it, when we add the four, right? We add the four. So I have 7 and I add the four. Can I add it? No. So then I go through my process and every number goes through the process. So it provides critical and analytical thinking. Why? Because we need to have a discussion with our numbers. In mainstream math, we don't do enough conversations. And so when we're doing it in Abacus, we want to say, oh, can I do it? No. So what do? I want to add the four. What do I do? Can I add the five? No, I cannot add the five. So then I know I have to plus the 10. So adding the 10, so I want to plus the 4. To plus the 4, I want to plus the 10 minus the 6. So my final answer is 11. And it's the same process with the subtraction. It's the same process with the subtraction. It's just, subtracting. So I'm not teaching you different strategies for adding and subtracting. Just like when we memorize our doubles. Doubles, if you've noticed, is only for addition. There is no such thing as doubles minus because that just means zero. So I don't understand in math, what in mainstream math, why do we teach something one way for adding and something different for subtracting? So in abacus, we marry the two and we compound the information. We compound our skill and we practice the principles. Okay, good. So, I have it. Okay. Somebody asked me if I can do -5 times that by 8, and I was just being kind of silly. And I was like, okay, I'm going to minus the 5. Can you see minus the 5? Right? Because you can't take a negative number. You can't take away, if I have 4 pens, if I have 3 pens, how do you take away 5 more pens? You can't. It'd just be 0. So I was going to do -5 is equal to -5 times 1 is equal to -5 is equal to 1. -5. Okay, wait. I was trying to figure out this. I was going to do a post on this. Okay, -5 times 3 is this. -5 times 4 is this. -5 times 5. You know what I mean? I don't understand when people keep asking me, can we do negative numbers? Like, no, we can't do negative numbers from a beginning, if that makes sense, right? Anyways, okay. So we're doing multiplication. Here, I think this is a really pretty number. Why? Because it's easy to show. Okay, we have, what do you have? We have 59 times that by 19. Okay, what are we doing? Oh, thank you, Princess. The negative 40. How do you show me as a physical product what negative 40 is? Number line is not a physical product. I don't know. I mean, that's above my pay grade. Negative numbers. All right, Mr. Clean, are you still here? I know the answer. That's fantastic. But can you show me what it is? Can you show me physically what a negative 40 is? Hola, KZ. All right. So, Mr. Clean. Okay, cool. So, what we're going to do, remember what we're going to do is we're going to look at our digits, right? We need to count our digits. 1, 2, 3, 4. Why are we doing it? Do you remember why? What do you mean by physical property? Objects. Can you give me minus 40 objects. You can't. Abacus is a physical place value, but that's still negative. This is not negative. This is still positive, right? Can you show me negative 40 cups? Can you show me negative 6 pens? You can't take away 6 from 5. That's not possible. No. That's why the question is that's why the question doesn't make sense in abacus. We do not use imaginary numbers in abacus. We use adding and subtracting. Can you show me every time I pass your life I get stuck? Instant learning mode. What do you mean you get stuck? Like you want me to teach you how to count? Is that what you want? You just want to review? We could do that. That's not a problem. That'd be easy. Easy, right? So I mean, I understand the question, obviously, right? We know what 5 times 8 is. We know how to do that. And then what do? Then we have to slap this negative sign. That's fine if that's how you want to do it. But I don't teach negatives on the abacus because I cannot show you how to take away. If I did 2, how do I do -9? I don't. 2 minus 9. How do you show that physically? I can show you abstract, right? I could draw you a picture. But apples, if I have 2 apples, how do you take away 9? How do you take away 9 apples? You can't. Okay, sorry. Interested in learning your abacus lessons? No, I mean instantly intrigued. What? No, okay, so you know how to count. Well, I don't know. I don't know what the question is. Like, I have books, so if they're interested, I have books. I have online classes, but they go through my books. I do one-on-ones, and I do one-on-ones. I have an online class that's self-paced, and then I have books. Like, I got books. I got books. I'm on my 10th book, right? I'm not sure what parts. So, and what we do is um, we learn the concepts. Oh, thank you. I appreciate that. And here's another question: is it for you or is it for children? And if so, if it's for children, how old are they? Because it all depends on how you talk to them, right? You don't want to talk to them like they're babies if they're 8 years old, but if they're young, right? So if you kind of give me more of a gauge of who I'm talking to, I can give you a better path if that makes sense. So like if it's for older kids, let's say 8, 9, and 10, then you could do the abacus mazes because this would be just bead recognition and understanding how to read the beads. So that's where I would start. However, if they're still learning their numbers, right? If they're still learning their numbers, then I would have them start with the preschool one, and they would start going through understanding um, how to read the numbers and how to write it as well. What an accomplishment. 10th book. I'm so proud. Thank you, Mr. Cleaning. Thank you. I appreciate that. Yeah, my TikTok shop is growing. So then this is the next one, right? You make these books. Yeah, these are all mine. These are all the ones that I've done, and I'm in the process of making more. And I try to make it interactive, and I try to make it intriguing so the kids can be understanding. There are still like the regular like numbers, right? But then this is like a hidden word. So you find the answer and you look at the number down here. So I have a whole path. I have, yeah. And then that's the 10, and then my tens are over here. So this is right now what I have. And then I'm working on the minus tens, and we keep going. And then I got to make, and then and then it's going to go all the way to multiplication and division. Division's it takes a little bit of time, but understanding all of this, and everybody has to start from this. You can't just jump into it, right? That's why I have, yeah, I want to make sure you understand, like, just the idea of like what we do is numbers, yeah, with formulas and stuff before I start going into multiplication. And the reason why is because multiplication is just fast adding. And when we're looking at multiplication, we still only need to know for multiplication, abacus only goes up to 9. We only need to know, we only need to memorize our 9 times table. That's it. The reason why is because after that it becomes redundant, and I'll show you why. We don't need to memorize anything higher than 9. It doesn't make sense on the abacus. Okay. And then we can also do division as well, but that's later. Okay. So, and then this is the other one. This is my laminated one. This is a really good, this, I like this one. And this is where you can have, this is where you can do a dry erase, and you can talk about, and then, obviously you can erase it. And then the way I organized it was really cool. We start with the plus fives, right? That's all. We always start with the adding of the five, and then adding of the five. I have a little tag here to tell you what we're looking at. So this is adding of the four. So when we're adding the four, and then behind the adding is the subtraction. So when we add the four, we want to subtract the four. It's the same thing with the three. We add the three, we subtract the three, and it's the same thing. And then we have, this is the fives, and then we have the tens, and the tens is the same thing. Tens is, plus the nine, and then you minus the nine. And then if I have plus the eight, you minus the eight. So that's kind of cool. And then at towards the end, after you go through all the numbers specifically, now there's a framework. This is the framework that I was showing you, as I show all the time. This is a process of, not a process of elimination. It's like a checklist, right? How do you do it if you can? It's like a workflow. That's what it is, a workflow. And again, I show you the addition side and I show you subtraction. Yeah. Yeah. All right. So if you're looking for printables, you're looking for workbooks, any online classes, or if you want private tutoring, that's what I do offer. So that's one of the things. But yeah. All right. I'm not just here on TikTok Live. I was actually in the process of making. Oh, this one's a beautiful one. In the process of making some how to make worksheets easier, because the problem is I have to curate all the questions. All right, so yeah, division is a bit hard. Doesn't mean I'm going to quit. Good, good. Don't quit, because it's really quite easy once you get the hang of it. And obviously, it's very different than mainstream math. So what we're going to do here. Four. 1, 2, 3, 4. We counted our digits. The reason why we count our digits is because we want to know where our number lies, right? So our number is going to be somewhere around the thousands. Somewhere. We don't know. But let's go see. Right? And then the first thing we're going to do is we call it distributive property. We call it distributive property. Property. This is an algebraic term, I believe, right? Distributed property. There's a lot of things that Abacus does that we don't have labels for. So I'm kind of like, I don't know, grabbing whatever I can. I was trying to do associative property, but we don't do it. We do substitution. All right. So the first thing we're going to do is we're going to understand, we go left to right. So we have 5 times 1. 5, well, 1 times 5 is equal to 5. 5 is a single digit, right? What do we do with a single digit? Do you remember, Mr. Clean? Hello, don't forget to smile. Hello, welcome, welcome, welcome. We're doing some multiplication right now. Mr. Clean, what do we do if it's a single digit? Blue bead. Not yet. We need to go to the one column over. Okay, the reason why is when it's a single digit, we want to make it a double digit. That doesn't make sense. Oh, it kind of does, because when we do time, right? Let's say our time is 10:07 or 10:06 a.m. Right now it's almost 10. We do double digit right here. Let's do 2 month, right? 2 month day, 2 months, 2 month day, 7, and then 2 month year. So we understand how to make a single digit 2 digits. That's what we want to try to do. So because we have a 0, 5, it will be 0, 5. And yes, thank you, Principal Martin. We bring down the 5. That's all we're doing. And then what are we going to do? We're going to do 9 times 1. 9 times 1 is equal to 9. Again, 9 is a single digit. I go back one column, right? 9, 0, 9. I add that. I'm done. No, you're not. No, you're not. So what we're going to do, what's next? Well, we're done with the 1. What do we do now? Well, we're going to do brown. We're going to do brown because I can't find anything else. Okay. We know we started off with the 4. Now we just go with 3. 1, 2, 3. We're counting again, right? Okay. What are we doing? We're doing 9 times 5. 5 times 9 is equal to 45. Whoa. Plus the 4, plus the 5. This is not the good one. All right. How do we add the 5? Now we're going to do is we're going to understand our formulas, right? We want to plus the 5. How do we add the 5 to this? We know plus the 5 is equal to what? Plus the 5 is equal to minus the 5 plus the 10. Minus the 5 plus the 10, 1, 0. Minus the 5 plus the 10, 1, 0. Does that make sense? Sometimes it's too much going on. So I will do this. What happens is now we can isolate our columns. We're going to minus the 5 first. So I'm going to take away the 5, right? Because that's what we need to do. What happens? We're going to add the 10 plus the 1 plus the 10. Thank you. Plus the 1 plus the 10. Plus the 1 plus the 0, right? Plus the 1 plus it. Can I add 1? No, I can't. How do I add 1? Remember, plus the 1 is equal to plus the 10 minus 9. So I'm going to plus the 10 minus the 9. And then what do I do? 81. 9 times 9 is equal to 81. I add the 8, I add the 1. I add the 8, I add the 1. Can I add the 8? Do you remember how to add the 8? Let me do that. Can we add the 8? How do we add the 8? Plus the 8 is equal to what? Plus the 10 minus 2. So what are we going to do? Plus the 10. Whoa. I just messed it up. Ah. Okay, 1, 2, 3, 4, 5, 9, right? And then we did this one. We did 45. Oh, there we go. That's 40. Right, 5. Okay, so then we do 81. Okay, got it. 81. So we add the 8, and we add the 1. 81. Yeah, sorry. That's not a good question. It's not a good question. Okay, let's go back. I have too much stuff. We have 59 times that by 1. I had a better question. This is not a good question. Now what we're doing is we're combining everything. So we did 4, right? 1, 2, 3, 4, right? So we did 1 times 5 is equal to 5. 5 is a single digit. I go back 1 column, I add the 5. Maybe I'll do a different question, or I'm going to continue. I'm going to continue on. We'll get a better question. Why is this not a good question? It's too many formulas for beginners. That's why it's not a good question. This is more like an intermediate question. Because we're doing 2 digits, this is not good for learning, right? But because Mr. Clean and Javier and Jose, and don't forget to smile, we've been here for a little bit, so it's easy. They understand the concepts. So the biggest thing is understanding these concepts. But because, yeah, thank you. And that's why. And so that's why I'm trying to find better beginner questions for multiplication, but it's tough to I have to curate those questions. So the reason why, so now we have this, right? Let me do a running total. Maybe that will help. So if I had 59, right? I have 59. But if you look, I have my 0 here, right? Ask ChatGPT. No, Chat doesn't know how to do it. I know why people stop using Abacus. That's not very helpful, Stevie. You know why? Because don't hurt people. All right. So we have the 9. Okay, so if you look, we have our 590. We have our 0. So when we're looking for an easier question, no, because the way Abacus is, it's there's not enough information out in the world to do it the Abacus way. Like a really easy question here. Here, this would be the better easy question. Here, uh, 53 times that by 9. Let's see if that one works, right? 53 times 9. So we know 9 times 5 is equal to 45. This is 3. 1, 2, 3. So I add 40 and I add 5. And then what happens, right? Then we do this. 9 times 3. 9 times 3 is 27. Can I add 2? Yes, I can add 2. I add 2, and then can I add the 7? Yes, I can add 7. So my final answer is 477. Hello, Apple user. 814. Ah, hello, Apple user 814. Yes, Abacus is fun. It does math for you. It doesn't do math for you. You just move the beads. You doing the math. That's the trick. You're doing the math. All right. Yeah, I think that's the yeah, that's why. I mean, it's easy to show one digit, but two digit gets a little bit, right? So it's always easier to show one digit. You can do we could do another one. We could do 3 times table, right? Here. 853 times that by 9. It's the same thing. I'm sorry, right? 1, 2, 3, 4, same thing. And then what we could do is we could do 9 times 7, I'm sorry, 9 times 8 is equal to 72. So you add your 7, you add your 2. And then 9 times 5, 9 times 5 is 45. Add my 4. Can I add 4? No, I cannot add 4. What do I do? If I cannot add 4, I know I can plus the 5 minus the 1, and then I add the 5. And then I have 9 times 3 is equal to 27. Can I add 27? Yes. I add my 2, I add my 7. Mr. Clean, I will have to find a better number. Yeah. So, 1 times table is easy because the 1 digits times 1 digit is a lot easier to curate. So that's what we do. I don't know if that made sense. If that was that too fast? Let me know. Let me see if I can find a better two-digit question. Um, no, maybe not this one. Maybe we do. I think it was like 3. Um, what are we doing? It was. I thought this was a better question, but it's not. I had a nice one too. Maybe it was a 2. The 2. Hmm, no, I want 2. 2. Yeah, I did it on my abacus with you. Yeah, yeah, 7,677. Good, 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 Mr. Clean. That's very good. Yeah, it makes sense, right? It's a prettier number because it's easy, right? This is what I call simple. Oh, not simple. We had a plus 10 here. What was the plus 10? Plus 10 was the 4? No, it was a 5. So, yeah, I'm just trying to find better questions. Um, oh my gosh. Hmm, what do we do? How about 16? Okay, how about this one? 23. We can do 23. 23 times that by 29. Maybe that's a better question. Not so much. Not so much, right? So we have, right? Okay, try that one. So we're going to count 1, 2, 3, 4, right? We're here. So we do 2 times 2 is 4. 2 times 2 is equal to 4. 4 is a single digit. I go back here and I add the 4. Sorry, 4. There we go. And then what do we do? 2 times 3 is equal to 6, right? 6 is a single digit. I go back one column, I add the 6. Okay, we're done. We're done with this one. So now what are we going to do? Well, uh, 9 times 2. 9 times 2 is equal to 18. So I'm going to add my 1. I add my 8. Add my 1, right? How do we know? Do we remember how to plus the 1? Plus the 1 was plus the 5 minus the 4. And then we need to plus the 8. Plus the 8 is what? Plus 8 is equal to plus the 10 minus 2. Plus the 10 minus the 2. Minus the 2. Cannot minus the 2. Minus the 5 plus the 3. Minus the 5 plus the 3. That's the 18. And then what? 9 times 3 is equal to 27. Add the 2, add the 7. Add the 2, again, we go back, how to add the 2. Plus 2 is equal to plus 5 minus 3. Plus the 5 minus the 3, and then we're going to plus the 7. Plus the 7. That's okay. That's okay. This is a lot of two-step equations. The two-step equations, again, it goes back to making sure that we really understand how to add and subtract the formulas. Yeah. Yeah, I think I got to get a better handle on the two steps. I can't do it on the fly. I think that's what it is. Because they're not pretty, they're not easy to understand. It's already difficult to try to figure out like what's going on. So, all right. Did that make sense, Mr. Clean? Because I know that was the question you're asking. Is there another one? I have an abacus sitting on my desk. Really? Himbo. I think I'm getting it. This is the first time seeing you talk about multiplication. Ah, himbo. Get your abacus out. It did make sense. Okay, good. But see, that's the thing, right? Because we know the formulas. We're understanding our formulas. Himbo. Does your abacus look like this? Yo, no, thank you, Mr. Clean. I'm still. What I want to do was I was going to do two-digit workbooks, but I was going to go through the process. It would be simple, plus 5, minus 5, but then it takes time to do it. But yeah, let me know if you have another multiplication question, Mr. Clean. We can do it, whatever you have in school. If it's a multiplication question, we can do it. I can show you. Okay, Himbo, I'm wondering, what kind of abacus do you have? Do you have this one? Um, don't forget to smile. We can do more multiplication if you like, or we can review adding and subtracting. So, Principal Martin, how are we doing? Javier, what's going on? You guys are a little quiet. I hopefully didn't scare you guys. Interesting. Okay, sorry. What are we doing? Okay. Do you know the hand abacus method? I see people. Oh, I'm just trying to get the hang of it. Oh, more multiplication, if you please. 13 columns, 2 buttons on top, 5 on the bottom. Okay. So, Himbo, okay, thank you. Don't forget to smile. We will do more multiplication. Let me just do a little review on how to read the Chinese abacus, because Himbo has a Chinese abacus. So, what I teach is the Japanese abacus, which is this one. You sound like the one that you have is the same, but yours is a Chinese abacus. And so the Chinese abacus happened before the Japanese abacus. And so Japan came around and said, you know what, we can make it more efficient, so we got this. So if you notice, this one is also what we use now modern. There's not too many people that do the Chinese abacus. There's still people, but they're like super old and they're about to die. So oh, thank you so much, Mr. Clean. I appreciate that. And what we're looking is it's exactly the same as the Japanese abacus. Not exactly. It's very similar. And when we're counting, we can count 1, 2, 3, 4, 5. Now, if you notice, because this is 5, what we're going to do is we're going to trade. right? We're going to trade in this with the top bead. The top bead will always be a value of 5 no matter what. So this is 5 and this is 10. 5 plus 5 is 10. So that's what this is, right? So when we're looking, we could do 5, 6, 7, 8, 9, 10. Oh, look, there's 5 here. So we got to trade it in and we do that. You'll notice that if I do this, this is 10. If I do this, this is 10. And then I have to trade it in again. If this is 10, I'm going to do that. So now we have 10, 0, and 1. When we look on the Japanese abacus, it's kind of similar. We do 1, 2, 3, 4, and then we have 5. 5, 6, 7, 8, 9, and then 10. Notice I have a 10 here, 1 and a 0. And that's it. That's how we count on the abacus. That's how you use it. When we're doing things, we're just moving the beads. So if I need to add 4, I'm just going to add 4. I just add the 4. So if I have, then this is 14. And then obviously you can do 94. So this would be 94. And then we have 100, right? 100. This one would be, I would go over here to do 100 because then I'd have this to be my ones place. So it'd be 0, 0, 1. 100, 200, 300, 400, and then 500, 600, 700, 800, 900, and then 1000. I'm not 1000, 1000. All right. So, how are we doing? We all right? Did that make sense, Himbo? Yeah? Okay. We are going to do, oh, Muller multiplication. Yeah. Yeah, I got to figure out how to curate. I got to curate the questions better. We could do, oh, you know what? Let's try this one. Maybe we do it the other way. What if we did 19 times that by 25? Maybe if that's better. Let's see. So what we're going to do, we're going to count our digits 1, 2, 3, 4. And then we go 1, 2, 3, 4. When we do it, don't forget it's distributive property. So how we have it is 2 times 1 is equal to 2. 2 is a single digit. I go back one column, I add the 2. And then 2 times 9 is equal to 18. So I need, oh, I'm sorry. Happy, thank you so much. You're a quick teacher, so I need to review, but happy to know it's Chinese. Yeah, it is Chinese abacus. I inherited it from my father who got it from the, yeah. And you know what's interesting? If you want to do it through the soroban, all you would have to do is just use the middle beads. So it is possible, if it is possible to modify it, not modify it, but it is possible to use the Chinese abacus as the soroban, as the Japanese abacus, because all it is you just move the top beads, and you can ignore the top bead and the bottom bead. So that's really cool that you got inherited from World War II. So then we do 18 plus the 1 plus the 8, right? And then we're done with this. We're done with the 2 because we had 38. But notice we're not going to do 380 because the abacus already does it for us. I got mine off of Amazon. Cool, right? So then we do 3. We're over here. 5 times 1 is 5. 5 is a single digit. 5 times 1 is 5. 5 is a single digit. I go back one column, I add the 5. We don't have enough beads to add the 5. What do we do? If we don't have enough beads to add the 5, what do we do? We need to plus the 5 is equal to plus the 10 minus 5. Plus the 10 minus the 5. And then we do 5 times 4. I'm sorry, 9 times 5 is equal to 45. Add the 4, add the 5, add the 4. To add the 4, what do I do? Plus the 5, plus the 4 is equal to plus the 5 minus 1. Plus the 5 minus the 1. And then plus 5. So my final answer is, anybody know my final answer? I have to go to work. I'll definitely be back though. Yeah, not a problem, Javier. Thank you. Hopefully I have a better multiplication question for you. See you later, Javier. Okay. So my final answer is 475. Thank you, Mr. Clean. Yes, thank you. Don't forget to smile. So what do we do? Now remember, right? Remember we need to know our formulas. That's why I start with learning our formulas first and then going to adding and going into multiplication. So that's the first thing. That the first step is to really be solid in adding and subtracting, because then when we add our multiplication, then it's a lot easier. I don't have a book for that. Um, that's not what I wanted. Uh, yeah. Okay. So, Miss Principal Martin, do you have any questions? Any specific questions about the abacus or the curriculum or so forth? But that would be the thing. Like, the thing is to understand we need to know how to add the 5, we need to minus the 5, we need to add the 10, we need to minus the 10, and then we have to do a mixture of 5 minus 5, 10, and then minus 10. This is a whole mixture. Once this is set, then we would have to memorize our multiplication facts, right? Multiplication facts. As we know our multiplication facts, we will also know how to do division facts, which is interesting. We don't have a division fact table. And what does that mean? Division facts just means that we need to know the opposite of. So um, if I have 3 times what is equal to 27, we need to know how to get to this missing multiplier. When we have 4 times what is equal to 16, this is like the beginning parts of understanding how to do division. But yeah, this would be the format. This would be the curriculum, and then it all depends on what the questions are, and you can ease into it. So the ones that I did show you in the beginning was a little bit much because it gets a little bit complicated. So the first thing we're going to do, so we had the adding of the 5, and then we did the 10, and then minus the 10, and so forth. So we can do more multiplication. I'm trying to. Oh. Okay, how about this one? 24 times that by 58. Let's see how that works. Is multiplication with decimals harder? No. It's just another place value. I hear that 987 times 654 is difficult in the abacus. It's only difficult if you don't know the formulas. So the formulas that I've been talking about is adding of the 5 and adding of the 10. So, I mean, we could do it, not a problem. But that's the thing is you need to know these formulas. We could do it. I'll show you how to do it. But you need to really know this formula. Um, and this will be the last question. Oh, wait, let me do this one. So we're still going to count to 4, right? 1, 2, 3, 4. And then what do we do? Um, so yeah, Himbo, we'll put a pin in that, and let me just finish this, and then we'll do that. So we have 10, right? 5 times 2 is equal to 10. So we have 1, 2, 3, 4, 10 and 0, right? 5 times 4 is 20. Add 2, add 0. We're done with this. Well, now we do 8 times 6. 1, 2, 3. 8 times 6. 2 is 16. Add the 1, add the 6. And then 8 times 4 is 32. Right? 32. 8 times 4 is 32. Add my 3, add my 2. And then we're done with this. So what's next? Well, we do 5, right? We do 5. 5 times 2 is 10. 5 times 2 is 10. Add my 1, add my 9. Add my 1, add my 1. What do we do? Add my 1. 5 times 4 is not 48. Add my 1. Don't have enough beads to plus the 1. Plus 1 is equal to minus the 9 plus the 10. Plus the 10 minus the 9. And then 10. Oh, that's a 0. And then 5 times 4 is 20. I add my 2, add my 0. Oh, that worked out. So my final answer is you just have to keep going. That's all. 1, 2, 3, 4. So it's 1, 4, 0, 4. That that worked out. It wasn't supposed to work out. But yeah, the decimal is not difficult on the abacus because it's just another place value. That's all it is. You're just going to go through it. That's all. All right. So now we have the final question. 987 times that by 654. Yeah, I got that too. One thing is we're going to change it up. Right, because I don't have enough beads on the other one. Okay. Let's see how to do this. How to do it. It's easy. It's easy. But the big thing is to understand your formulas, right? So we're going to count to 6. How do we know? 1, 2, 3, 4, 5, 6. I'm going to be serious now, not use markers. 1, 2, 3, 4, 5, 6. So we're going to start from here. Oh yeah, you can't see that. Okay. So 1, 2, 3, 4, 5, 6. We do 6 times 9. 6 times 9 is equal to 54. We add our 5, we add our 4. 6 times 8. 6 times 8 is 48. I add 4, I add 8. To add the 4, what do I do? Plus 4 is equal to plus the 5 minus 1. Plus the 5 minus 1. And then I have to add my 8. 6 times 7. 6 times 7 is 42. I add my 4, I add my 2, I add my 4. Now I know if I add my 4, I have to plus the 10 minus the 6. So I have to plus the 10 minus the 6. So I'm going to plus the 10 minus the 6 and then plus the 2. I'm done with my 6. And then I go 5. 1, 2, 3, 4, 5. I'm over here. 5 times 9, right? 5 times 9 is 45. I add my 4, I add my 5. My 4 is plus the 10 minus the 6, and then add my 5. And then I do 5 times 8. 5 times 8 is 40. I add my 4, I add my 0. I add my 4 plus the 4 minus the 6, and then my 0. 5 times 7 is equal to 30. I'm sorry, 5 times 7 is equal to 35. I add my 3, I add my 5. I add my 3, right? Plus 3 is equal to plus the 5 minus 2. And then I add my 5, right? And then what I do? 1, 2, 3, 4. 4 times 9. 4 times 9 is 36. I add my 3, I add my 6. Plus 6 is equal to plus the 10 minus 4. Plus the 10 minus the 4. Plus the 10 plus 1. Plus 1 is equal to plus 5 minus 4. Plus the 5 and then plus minus 4. Minus 4. Minus 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. 4 times 8. 4 times 8 is 32. Plus the 3 plus the 2. 4 times 7 is equal to 28. Plus the 2 plus the 8. That's my answer. Ha! So my answer is 645,498. Okay, so is this called a Soroban technique? No, it is called the Abacus method. It's all abacus. It just depends on what kind of abacus you're using. So the Soroban is a Japanese abacus. Yes, thank you, Mr. Clean. So she's just using a longer soroban. Yes, exactly. So this one is a 13 column abacus. This one is a 7 column abacus. It's all the same. It just means to be, because size matters. And if I look at it, I have my ones, my tens, I'm sorry, my ones, my thousands, my millions, my billions, my trillions. But if you wanted to track the national debt, then you can use a bigger number, a bigger column, which has 23 columns. So the 23 columns can do a lot more digits, but that's all it is. It's just a bunch of digits. It's not, is it not? I gotta check. Maybe I messed it up somewhere. 897 times up by 654. No, I have 645,498. That's what I got. Hello, A Talk. Welcome back. I don't know how you got the one. I mean, we could do it again if you want. um, we could do it again, but it you outsmarted ChatGPT. you know, Chat's not the greatest, right? Oh, thank you. Thank you for your time. This has been very helpful. Really? Thank you. I hope so. I'm so happy it is helpful. Try to muddle my way through the whole abacus of multiplication stuff. It's one thing to keep track of everything too. You have to keep track of everything. But thank you. I will see you soon. Don't forget to smile. Don't forget to smile. I have the correct algorithm. I'll have to correct the algorithm. Thank you. Yeah, not a problem, Himbo. Good luck. Come back soon. It's still learning, but that's awesome that you still beat it. Yeah. Everybody keeps asking me, like, just use chat to do like the questions. The questions themselves are very specific. Why? Because there's a pattern in it and chat doesn't know it yet. Obviously, if I start putting in my stuff, chat will know me. So when we look, right, in the beginning we started off adding the can we add the beads, right? That's what these are. Is there enough to add the beads? Yes. Then after that we figure out, okay, what's the next thing? We have to add the 5. This is what adding the 5 is. And then afterwards, we're adding the 10. This is what adding the 10. So the abacus method is there's a little bit of thinking and critical thinking involved that needs to happen. And curating the questions take a little bit of time. So the old school and brain power is unmatched. Thank you. Yeah. Um, yeah, but this is like old. Abacus time. Yes, Omar. Thank you. Let's go. Exactly, your smarts plus common knowledge puts you in another category compared to the bot. Yes, yes. And I'm trying to correlate mainstream math to abacus, and that there's no information out there, so that just all came from my prefrontal cortex. Thank you. I appreciate that. What is the difference? I'm sorry. What is that different compared to just knowing place value? No, it's exactly the same. ChatGPT brushed it off as a typo, but thank you for your correcting it. You're welcome. It's easy to use a calculator, right? But see, the thing is understanding how to do the things, how to move the beats. So, orbital nonsense. It is exactly like place values, and that's the greatest thing about the abacus is that it provides place values and it keeps track for you, and that's cool. So, you're able to relate. I'm sorry. Yes, but you are able to relate it to today's abacus is crazy. And yes, that's my point. Yeah, thank you. I appreciate it. Freestyling math. Thank you so much. I appreciate that. But I do, I do, I am, I am honored, just so you know, I am honored when people want to learn how to use the abacus. There's a lot of people that say, wow, that's really complicated. I'm out. But there are those that really are interested and understand that it is a simpler method as opposed to what we do in mainstream math. So there's like box models and so forth. And so I don't know how to do that. I don't know. I mean, the lattices, right? The matrices and all whatever they do, that sounds really interesting. However, it is interesting that we have to still count it as opposed to memorizing. We still need to memorize our multiplication fact. If you need to use it this way to help you to memorize, then that's great. But I don't focus on this sort of strategy. Abacus method is a very specific methodology and it's a framework. And it is not just mine. It's everybody around the world that learns abacus. This is what they do. Thank you, Apple user. Sideshow. Thank you so much for your appreciation. Mr. Clean, you're the one who got me buying my very first abacus. It's gotten more difficult because the rules want us to be, yeah. And that's the interesting thing, right? Like, it's so interesting on how some people, like, this is fine, right? But it's the same thing as if you group everything, right? And I have 3 times 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. It's the same thing, but it just looks cooler to do it this way. Wait, 1 2 3 4, right? 1 2 3 4. 1 2 3 4. 1 2 3 4. So it's kind of the same but just different. um and it's just a different way of thinking, which is great. And it's a little bit more, I don't know, efficient, I guess, because you're counting the connections, which is cool, but I don't teach. The way I teach is I do additive addition for multiplication. So here is one of my posts, right? There was the question like, how do you do 5 times 8? So in Abacus, what we do is we do 5, right? Plus another 5, there's not enough. To plus another 5, what do? We have to plus the 10 minus the 5. And now you get to see the number pattern. So we add the 5, we're at 3. And then we add another 5, there's not enough. We're at 4, right? When we add the 4, 5 times 4 is 20. But it's add the 5 is plus the 10 minus the 5, right? And then we do it again. We add the 5. Is there enough? Yes. And then what do? We add the 5 again. There's not enough. We plus the 10 minus the 5. So 5 times 7 is what? 35 plus 3 plus 5. We add another 5. 5 times 8. Do we have enough? No. We want to plus the 5. I'm sorry, plus the 10 minus the 5. So you see the number pattern. That's what I find it very interesting. It's a number pattern. And it's really interesting to see it on the abacus. Like, you can't see this because it's very abstract. So it's better to be able to show the no. I'm sorry. It's better to be able to know both. I think still I feel dumb knowing only one. You will, if you continue with my live sideshow, you're going to know it all. Yeah, you're welcome, Himbo. Thank you for off to work. Thank you for joining. Thank you for the questions. Let me know if you have any more questions about arithmetic. Yeah, anything on the abacus, it has to be positive arithmetic, meaning that it cannot be a negative number. Like, I can't do 2 minus 5 because you can't take away 5 from here. I'll see you soon. Mr. Clean, you're funny. But you gotta go to school. You gotta be in school. So, but soon, summer is coming. Right? And there's gonna be time off. Are you taking summer school, Mr. Clean, or are you gonna stick around? So, Principal Martin, I don't know if you're still around. If you have any questions, I'm doing work, playing a game, and yet you're still. So you got me. I appreciate that. I have yet to see multiplication done. Hey, Crush, Star. Okay. Nope, I'll send my doing abacus. You're so funny. Oh my gosh, that is hilarious. That's hilarious. Yeah, that my goal is to try to do multiplication books going all the way to, I think we're going to do 4 digits or 5 digits together. But then after after 5, I think it gets a little after 5, I think it becomes uncalled for. So I don't know if I'll go to four. I might go to four because I think three times three is a little much. 3 digits times 3 digits is a little much, I think. But it all depends. I mean, if there's more, if people are interested, if they follow through and they are interested in it, I'll probably do it. But I think I'm only going to go to 3 digits for my multiplication. And so what I was going to do is I was going to break it up. There would be one book for two times table, one book for the three times table, and then again, it will go all the way to nine. These are all separate books. That's the idea. That's my plan. And then obviously, if it goes into more, right, we'll see if I need to do any more. But that's the initial plan, right? These are all my multiple. And then from here, I got to do two digits times 1 digit, and then I do 3 digits times 1 digit, and then I do 4 digits times 1 digit. I don't know if I'll do five. And then after that, we'll do the 2 digits times 2 digits. I don't know if these will be separate books or if it's going to be all at once. We'll see. But that's like the plan. So, all right. All right. That was the last one. If anybody else has any more questions, I am going to sign off. It's been a little bit. How are we doing? Any other questions? Thank you, Mr. Clean. I love your plan. Thank you. Thank you. I appreciate that. Yeah, that would be after the adding and subtracting. Yeah. So I still have a fair amount to go. I'm trying to get to like 200 books. So we'll see. Did you go to college? Geoff? Yes, I did go to college. Are you in college, Geoff? Hey, ATalk. I'm sorry I'm late. No, I'm sorry. I'm sorry. I'm actually gonna sign off actually. But I'll see you tonight. Tonight's Friday, so I'll probably be around probably about 8 or 9. Did you you didn't? Oh, that's okay. You don't need to go to college to know abacus. You don't need to go to college to know abacus. And abacus is not taught anywhere. Okay, ATalk, thank you so much for stopping by. I appreciate that. It's good to know that you guys are still kind of stop by and say hi. Jeff. Yeah, Jeff, you don't need to know college, right? College doesn't teach you abacus. That's why I'm here. I am here to spread the good word of abacus. Okay, Mr. Clean, I'll see you soon. I'm glad I stayed around a lot longer this time. Yeah, I'm in 10th grade. Oh, yeah, see? Oh, yeah, hey, ATalk. See, Jeff, only 2 years. That's okay. That's okay. You don't need to go college to know abacus. But I have to remember there's a bunch of kids watching me, so I can't be like really mad. There's a lot of kids that'll be like, "What's the point?" I'm like, "You guys are too old now. You guys are already giving me attitude." Not you, Jeff. I'm just saying in general. Ah, hello, Reeves. Welcome. Thank you for the heart me. Yeah. No, I appreciate your questions and they're very sincere, right, Jeff? Like I want to make sure that it makes sense. If it doesn't make sense, then we can go back and we can make it understand. But learning the abacus will help just to what is it like build more solid foundation for arithmetic. Arithmetic is adding, subtracting, multiplication, division. So, but I do have to remember there's a lot of kids that watch my posts. There's a lot of kids on TikTok. And I have to remember that and I can't be mad. I can't be mad because they'll be like I am yeah. I can't be mad because people are like that's too much. I'm like, "Yeah, okay, then you can move on. You don't need to be here." You know what I mean, Jeff? So, anyways, yeah. I'm just here to teach math. I'm just here to spread the good word of the abacus. If you want to stay, that's great. If you don't, that's fine too. There's no harm. But it gets I think it gets a little bit when people are like, "Well, that's very complicated." No way. We'll explain in kind. Yeah. Yeah. I mean, that's the one thing, right? Like it is a lot when you look at it. But when I break it down to the simple things, right? And then when I break it down to the simple things, they're well, that's too easy. I was like, "Ugh, okay, you shouldn't have to change anything. Thank you, sideshow. No, I don't. But no, you know what I do need to do is I need to change my attitude and not be so abrupt about it. It's hard to just. If it's too hard, just keep watching and learn, or yeah, or just leave. Doing a great job. As someone who hated math, I was told about it, and I'm here for it. You know, I truly believe everybody and anybody can learn just with the right tools, and I truly believe that. And as questions go through, there's a lot of people are really sincere about they don't understand, and we'll just break it down even more. So I don't understand, why people say that. And I don't understand why people, yeah, it, maybe it doesn't connect, but don't forget it's unfamiliar, right? Because it's unfamiliar, don't it should not be taken, it should not be taken too, it shouldn't be taken negative. My tool is your teaching. You guys, you guys are so funny. But you know what? Oh my God, Mr. Clean. Just so you know, here's my soundboard. It's so fun. So you have this one, right? And then there's this one. You weren't here for this one. I don't know if you were here for this one. You guys are really young for this one, but this was a very old movie. I don't know if you know, but in Arnold Schwarzenegger, he had this one movie called Total Recall. And this is where the alien was inside the guy's stomach, and he wanted to tell Arnold Schwarzenegger to open his mind. Then there was this one. You know this one. One decent teacher for me. I was great with money and weight, so she related it for me. Yeah, I could see that. That's the good thing, is when people can relate it, right? And that's the thing. And then we do power up. Yeah, that's the matrix. This one, that's the matrix. This one is that's that's the Cars tunes where there was Tokyo Mater goes to Tokyo Mater. And then there's the power up. Everybody knows power up because it's Mario. And then I did this, or this one. Then I have this one. I like this one a lot. I like that one. And then I'm trying to get this one, but it doesn't sound so good. I don't know about that one. I just made the best grilled cheese. That's awesome, Jeff. Charizard has more soul than Pokemon. How many you got? How many do you got? I got 11 right now. My last one is this one. That's my last one. I don't know about that one. I have to figure out that one. But then the hurt people, I like that one. But I got to get a better one for that one. The sounds fun when I'm sorry. The one sound funny more than serious. I don't know why. Yeah. Hurt people. Yeah. Yeah, that one came from Bullet Train, and Brad Pitt, was the one that said it. So I want to get a better sound bite for that one. Hurt people. All right. Thank you guys. I am going to sign off. But yeah, that's my little soundboard. It's better than the defaulted soundboard that everybody uses. Yeah, I gotta go. I gotta go too. Yeah, no, thank you, Jeff, for stopping by. Thank you. I appreciate you stopping by. And you know what? If you want to continue on, that's great. I'm happy that you want to learn more about adding and subtracting and make it better. Slightly chuckle, non shy. You can definitely get you one. Have a good day, Sideshow. Thank you so much. It was nice to meet you too. I appreciate all your comments and your compliments. Thank you. I appreciate you. I missed it. I'm sorry, X-Men. The Angel, I'm sorry. Wait, we'll try again tonight. It's either going to be 8 or 9. It just depends on what time dinner is. See you later, Mr. Clean. See you later. See you later, X-Men. And I'm happy to meet you, Sideshow. Thank you so much. All right. Honestly, thank you. Keep up the I thank you. I appreciate that. I appreciate that. All right. Have a good day, everybody. Have a good day. And I'll see you guys all in my next live. Bye.